This is a video for the final review in my Calculus 2 class. The directions say to evaluate the integral. Now, let's take a look at some examples of what this looks like. So, let's take a look at example 1. Suppose I have the integral of 1 over 2t squared plus 3t plus 1 dt. This is a classic partial fraction decomposition problem. So I could write this as 1 over 2t plus 1 times t plus 1 dt. So I just factored the denominator. Now 1 over 2t plus 1 times t plus 1 can be written as a over 2t plus 1 plus b over t plus 1. So 1 equals, I'm going to go a times t plus 1 plus b times 2t plus 1. So 1 equals at plus a plus 2bt plus b. But this says 1 is. Now I'm going to combine the first term with the third term and factor out a t. So 1 equals a plus 2b times t plus a plus b. So we have an equation that involves t, and we have an equation that involves constants, which I'll call t to the 0. So a plus 2b has to equal 0. A plus b has to equal 1. Okay? Now, there's a few ways you can do this. What I'm going to do is solve for a in terms of b. So a equals negative 2b. So I can come down to the second equation and replace a with negative 2b. So negative 2b plus b equals 1. Negative b equals 1. So b is negative 1. And if b is negative 1, a is negative 2 times negative 1, which is equal to 2. I just replace b with negative 1 up here. So far. So we got the integral of 1 over, this is 2t squared plus 3t plus 1 dt. This is equal to the integral of. Now, I'm going to come over here. Remember, a is 2. So this is 2 over 2t plus 1. Then I'm going to go minus, and then it's 1 over t plus 1. And when it's all said and done, I get natural log of the absolute value of 2t plus 1 minus natural log of the absolute value of t plus 1 plus c. You get to here, I'm pretty happy. And that's how we do the first example involving partial fraction decomposition as the technique. I want to give you another one that involves partial fractions. And so we'll call this example 2. And this is the integral of x squared plus 8x minus 3 divided by x cubed plus 3x squared dx. So this is the integral of x squared plus 8x minus 3 divided by x squared times x plus 3 dx. So this is, again, a partial fraction decomposition type problem. And so I'm going to get x squared plus 8x minus 3 divided by x squared times x plus 3. So this is a over x plus b over x squared plus c over x plus 3. And this is a good problem, okay? Now, I'm going to get the numerator, x squared plus 8x minus 3 on the left side. On the right side, I'm going to get ax times x plus 3 plus b times x plus 3 plus cx squared. So x squared plus 8x minus 3 on the left is ax squared plus 3ax plus, right? So notice I'm just distributing the ax inside to each term within the parentheses, okay? And then I'm going to go bx plus 3b plus cx squared. Just like this. So x squared plus 8x minus 3. And then what I want to do is I want to collect the x squareds together, okay? And then what I get is a plus c times x squared. And then I'm going to collect the x terms and factor out the x. And so I get plus 3a plus b multiplied by x. And then I get plus 3b. And then this makes it really straightforward to set up our system. Okay, so we have an x squared equation, an x equation, and a constant. So a plus c has no choice but to equal 1. 3a plus b has no choice but to equal 8. And then 3b must equal negative 3. But if 3b equals negative 3, that tells me b is negative 1. And then it's just a trickle-down effect. So 3a minus 1 equals 8. 3a equals 9, and then that tells me a is 3. But if a is 3, that tells me c must be negative 2. So we have b is negative 1, a is 3, and c is negative 2. And so now, when we go, I'm going to use this and plug the values for a, b, and c in. So the integral of x squared plus 8x minus 3 divided by, and then in the denominator we have x cubed plus 3x squared dx. So this is the integral of a, which is 3. So it's 3 over x minus. And then remember, b is negative 1. And so it's minus 1 over x squared. Okay, now let me write that a little clearer. So we got minus 1 over x squared. And then c is negative 2. So it's minus 2 over x plus 3 dx. And so this is 3 natural log of the absolute value of x plus 1 over x minus 2 natural log of x plus 3 plus c. And these are two examples that involve partial fraction decomposition. And I want to give you one that involves trigonometric substitution. So we'll call this example 3. And suppose I give you this one. Suppose I have the integral of 1 over x square root of x squared plus 1 dx. So off the get-go, I'm going to draw a picture of a triangle. Okay? And I'm going to label the hypotenuse the square root of x squared plus 1. The side opposite angle theta is x, and then the side adjacent to angle theta is 1. And so x equals tangent theta. Dx is secant squared theta d theta. Okay? And the square root of x squared plus 1 is equal to secant theta. Now, this is all substitution all the time. So we have the integral of 1 over x square root of x squared plus 1 dx is equal to. Now, wherever I see an x, I'm going to plug in a tangent theta. Wherever I see a square root of x squared plus 1, I plug in secant theta. And then remember, dx is secant squared theta d theta. And so this is the integral of secant theta divided by tangent theta d theta. But if we remember, I claim this is going to simplify down to the integral of cosecant theta d theta. Okay? And so this is equal to natural log of the absolute value of cosecant theta minus cotangent theta plus c. But let's go back to our picture. Here's theta, here's x, 1, and the square root of x squared plus 1. So we just have to think about what's what. Cosecant theta, right? So if I replace, cosecant theta is the square root of x squared plus 1 divided by x. Cotangent theta is 1 over x. So we get the natural log of the absolute value of square root of x squared plus 1 over x minus 1 over x plus c. And then just writing this as a single fraction, we get the natural log of the square root of x squared plus 1 minus 1 divided by x plus c. So here's an example of an integral involving trigonometric substitution. Like so. So I wanted to give you another one that involves trigonometric substitution. So I'm going to go ahead and do this one. This will be example 4. If I have the integral of 1 over the square root of x squared minus 4x. So believe it or not, this is a trigonometric substitution. The way this works is you have to complete the square. What is half of 4? Half of 4 is 2. And then 2 squared is 4. And so what I'm going to do is I'm going to add 4 and then subtract 4 accordingly. Because I want you to watch what this turns into. If I add 4 and subtract 4, that's just adding 0, okay? And so this is the integral of 1 over the square root of x minus 2 squared minus 4 dx. Now, there's a couple of choices you can do, and it depends on what you're comfortable with. We can do a u substitution so it looks like what we're used to, right? In fact, I'm going to do that. I'm going to let u equal x minus 2. du is 1 dx. So this is the integral of 1 over the square root of u squared minus 4 du. So we're going to draw a triangle, and I'm going to label this angle theta, okay? It's a difference of squares, right? So what we have is u is the hypotenuse. I'm going to call 2 the adjacent leg, and then I'm going to call square root of u squared minus 4 the opposite leg, okay? So what we're going to do is we're going to say u over 2 is secant theta. Let's write that a little clearer. Multiplying both sides by 2, we get u equals 2 secant theta. du is secant theta, tangent theta, d theta. Right? And then square root of u squared minus 4 divided by 2, opposite over adjacent, is tangent theta. So the square root of u squared minus 4 is 2 tangent theta. And so the integral of 1 over the square root of u squared minus 4 du. Now we get to systematically plug things in. So I'm going to replace square root of u squared minus 4 with 2 tangent theta. So it's 1 over 2 tangent theta. du is secant theta tangent theta d theta. Like this. And let's double check, right? So u is 2 secant theta. du is, oh, let's be careful, right? What did we miss? So du is 2 secant theta tangent theta d theta. And we just put in the 2. And so when we go to plug it in, I want to put that extra 2 in. So I'll put that right there. And notice how the 2's cancel, right? The tangent thetas cancel. And what we get is the integral of secant theta d theta, which is natural log of the absolute value of secant theta plus tangent theta plus some constant c. Now we get to plug stuff in. So this is natural log of. Now let's not forget, when we go back, secant theta is u over 2, right? Tangent theta is square root of u squared minus 4 over 2. So we get u over 2 plus the square root of u squared minus 4 divided by 2 plus c. Okay? But let's not forget what u is. If we go back, u is x minus 2. So we're going to write u is x minus 2. And so this is natural log of x minus 2 plus the square root of x minus 2 squared plus 4, all divided by 2, plus c. Now, one final step. We can write this as natural log of, by the way, that should be minus 4. So we get natural log of the absolute value of x minus 2 plus the square root of x squared minus 4x plus 4 minus 4, right? Then I'm going to go minus natural log of 2, that's properties of logs, plus c. The 4's cancel. And this minus natural log of 2 can get absorbed into the constant. And so when we write a final answer, we're going to get natural log of the absolute value of x minus 2 plus the square root of x squared minus 4x, okay, plus c. And that's how we do trigonometric substitution. That's example 4. And I want to do just a quick example here. We'll call this example 5. This one is a really kind of a little bit of think outside the box. Maybe, maybe not. It depends on if you guys see it. So if I have x plus 2 squared, and I want to multiply by x plus 1 to the 20th, and integrate that, what would you do? This is a fantastic question. Absolutely fantastic. And it will be really interesting on what you would choose for u. It's a u substitution problem. So I'm going to write this as the integral of x plus 1 squared times x plus 1 to the 20th dx. So I'm going to let u equal x plus 1. du is 1 dx. So when I make this integral easier, it's the integral of u plus 1 squared times u to the 20th du. Okay? Well, this is the integral of u squared plus 2u plus 1 times u to the 20th du, which is the integral of u to the 22nd plus 2u to the 21st plus u to the 20th du. So all I did was distribute the u to the 20th inside. And so I get 1 over 23, u to the 23rd, plus 2 over 22, u to the 22nd, plus 1 over 21, u to the 21st, plus c. And I'm done. 1 over 23 times x plus 1 to the 23rd, plus 1 over 11 times x plus 1 to the 22nd, plus 1 over 21 times x plus 1 to the 21st, plus c. And that's a good stopping point for this video. So this is a video on the final review, and we did 2 examples of partial fraction decomposition, 2 examples of trigonometric substitution, and then I did 1 example of a goofy looking u-sub. And then I'll make another video where we'll do integration by parts. because I want to make sure we review our integration by parts. Okay, all right, thank you.